This is the 2009 relative velocity question. Two cars A and B traveling along straight roads. We can see here A is traveling at 15 meters a second and B at 20 meters a second, and at a certain instant both are 800 meters from the intersection. Okay, B will get there first, won't he, because he's traveling quicker. How long is it going to take him? 800 over 20. This is for B. It's going to take him 40 seconds to get to the junction. A in that time will have traveled 15 by 40, 600 meters. So we have a diagram here where A is 200 meters away from B. So if we get their relative velocities, we'll be able to get their shortest distance. So the velocity of A is equal to, he's going in a positive I direction at 15 meters a second, 15 in the I direction, plus 0 in the J direction. The velocity of B is traveling positive north, so 0 in the I direction at 20 meters per second, 20 in the J direction, and the velocity of A relative to B is going to be equal to the velocity of A minus the velocity of B, which is equal to 15 minus 0, so just 15 in the I direction, and 0 minus 20 in the J direction. And then, I won't do it here, get in the way of my diagram, the magnitude of the velocity of A relative to B, because we're going to need this is equal to the square root of 15 squared plus 20 squared. Both of those divide by 5, we'd have a 3 and a 4, so your answer will be 5, and multiply that by 5, we get 25. So 25 meters per second is the speed, the relative speed, and we may need direction as well in this diagram to get the shortest distance. The inverse tan of 20 over 15 is from that 3, 4, 5 triangle, 4 over 3, which gives 53.13 degrees. You practice them, you'll get that. So our relative velocity, A relative to B, positive minus, down in this direction, positive minus velocity of A relative to B. So this is my shortest distance. I have my hypotenuse and I have my angle in here. We'll call it the angle A. Put my angle A in 53.13. And then I can get the shortest distance x. So we have A, we're looking for the opposite, so x is going to be 200 by the sine of 53.13, which will work out evenly. X is going to be 160 meters, works out to be. And then the distance each car is from the intersection when they are nearest to each other. Okay, well, we need to find out this distance here and then the time taken to get there. So let's find out what y is. Well, we can do it based on Pythagoras. Y is equal to the square root of 200 squared minus 160 squared. And if this is your 3, 4, 5 triangle, that will give an answer of y is equal to 120. So now we have this relative speed along here was 25. So how long has it taken traveling at 25 meters a second to go 120 meters? 120 divided by the 25. That will give, well, that'll be 4.8, 4.8 seconds is the distance each car is in the intersection. So we need to find out, well, A is traveling at 15 and B 20, 15 and 20, 15 by 4.8 and 20 by 4.8, and that's 96, 15 5s are 75, minus 3 is 72 meters. So he was 200 meters, 200 minus 72, he's now 118 meters away from the intersection, and this guy is 96 meters past the intersection. That's all I was asking this question. Yep.